One important property of a linear equation is its slope. And in this presentation, we're going to talk about how we can use a formula to calculate that slope given 2 points. We can find the slope of a line that passes through those 2 points. So let's start by reviewing what we already know about slope. So when you first learn about slope in pre-algebra, you learn that the slope is the ratio of the rise to the run. And oftentimes we'll say slope is rise over run. I'm sure that sounds familiar to you. The way that you pick out the rise and run off a graph is you draw a triangle that connects the two given points on that line. And the way you do that is simply to start at the left-hand line and draw a vertical segment until you get immediately across from the second point, and then you draw a horizontal segment. Now, the number of squares that you went up or down is called the rise, and the number of squares that you went left or right is called the run. Now, what we usually say is that when you move up or right, you're heading in the positive direction, and when you move down or left, you're heading in the negative direction. So you can see in this particular picture, my rise actually went down 4 squares. So I would say that my rise is -4. My run went to the right 4 squares, so we would say that the run is +4. So in calculating the slope over here, I would say that the rise is -4, the run is 4, and I would go ahead and simplify that fraction. Well, -4 divided by 4 is -1, so the slope of this line is in fact -1. Now what you're going to find out in a few minutes is that in algebra class we use the variable m to represent slope, lowercase m. So I'm going to start using that variable now. The slope of this line is -1. Let's try that process again. We want to start at the left-hand dot, draw a vertical segment toward the right-hand dot until we get straight across from it, and then draw a horizontal segment until we hit it. This time we went up, which is positive, and right, which is positive. So both numbers are going to be positive. The rise was 4 squares, that's this measurement here, and the run was 2 squares, which is this measurement here. And so my slope, again, which we're going to label as m, is +4, up 4, and right 2. 4 over 2 is 2, so our slope is 2 this time. Now, one thing I want you to notice, the line that we calculated the slope for on the previous slide was slanting downward from left to right. It looked more like this. This line that we're working with now is slanting upward. The slope of this downward line on the last slide was -1, and the slope of our line here is +2, and it turns out that's always the case. When a line slopes downward from left to right, it's going to have a negative slope. When it slopes upward from left to right, it's going to have a positive slope. So that's something that we want to add to our notes, or jot this down so that you always remember that. In fact, there are 2 other important types of slope that you should keep in mind as well. Let me show you what I mean in a little table. So as I mentioned, there's an easy way to tell if a slope's going to be positive, negative, 0, or undefined. When a line goes upward from left to right, that's a positive slope, as it says in the table. When it goes downward, ooh man, I'm not spelling that very well, am I? Let's try this again with a little better penmanship. Downward is a negative slope. Horizontal is a zero slope, big old zero. And then vertical, I'll put down here, vertical is an undefined slope. Now let me tell you about this undefined thing. That is terrible penmanship. Okay, here's why it's undefined. Because you'll notice when you try and draw a triangle here, you can't. All you have is a rise if you pick 2 points out. You can go up and down, but you can't go left and right. So you'd get some number. Let's say it's 4, but you'd be dividing by 0. 4 divided by 0 is an undefined value. We can't divide by 0. So what we say is that the slope of a vertical line is undefined. That's why this is written as undefined here. It's similar when you do a calculation for a horizontal line, except the 0 is in the numerator, right? You can move left and right, but you can't move up and down with this line. So when you do your slope calculation, oftentimes you'll get a 0 over some number, let's say it's a 6, and you can do that calculation, that is a 0. So all of the horizontal lines will have a 0 slope, and all of the vertical lines will have an undefined slope. Most often we're going to focus on the positive slopes and the negative slopes. They're more interesting. So finding slopes off of a graph where the points are drawn right on there is pretty easy. We use this triangle method where we draw in the right triangle, we figure out what the rise and the run are, we make the fraction, we reduce it, and we get a slope. But that's not always efficient. In fact, more often than not, you're going to be given 2 points and you're going to need to calculate that slope, and you're not going to feel like drawing a picture. The points might not be close together, like the examples that we've given here, and so the picture might not be very easy to draw, or you might just need a quick rate of change between 2 different instances of 2 quantities. And so what we've done is we've developed something called a slope formula where we can do this. We can find the slope of a line through 2 given points without a picture. Okay. To do that, we need to go back to the picture and find out what we were really doing. So take a look at this graph of this linear equation, and let's go ahead and get the slope with a rise over run like we did before. If we're going from left to right, we'll start with the rise, which turns out is going to be up here because this dot is above, and then we'll go over and we'll draw the run in, and you can see that the rise was 3 and the run was 1, 2, 3, 4, 5 spaces. So the slope with the rise over run method is 3 over 5. But let's break this down and figure out what we're really doing. I think you'll agree that the coordinates of this point are -1, 0. And the coordinates of this point are 4, 3. I had to count it out there just to make sure. Now check this out. The way we measure distance in the coordinate plane, and that's what we're working on when we have these grids. This is called a Cartesian coordinate system. René Descartes is the man who developed this technique for representing points in a plane. The way we measure distance in a plane like this, in a grid, is we subtract right minus left or top minus bottom. So if we want to find out how long this run line is, this rise line is, without having the picture, we simply need to know where it ended, which is right here, and where it started, which is right here. And the only numbers we're worried about are the y values. So this guy ended at 3 and started at 0. So the rise is really 3 minus 0. We can play the same sort of game with this horizontal run segment. It ended here and it started here, right? It ended out here at 4 and it started at -1. So this run distance is 4 minus -1, which sure enough is 5. Now, if you're paying attention here, you'll notice that all the numbers I used are actually the numbers that are given in these coordinates. In fact, we could write out the calculation for the slope m like this. To get the rise, we did 3 minus 0, and to get the run, we did 4 minus negative 1. Notice, both of these numbers came from this point, and both of these numbers came from this point. The y values were on top, and the x values were on bottom. And so, what we can do is we can generalize that, and we can make our slope formula. And then we won't need a picture anymore. Let me show you what I mean. So the way we generalize this, and we have a habit of doing this a lot in mathematics, in particular in algebra, is rather than assigning numbers to these points, we assign variable names. So even though this is the same picture I had in the last problem, it could be any picture of any linear equation. And we could, as long as we have 2 points, we can assign each of the points a particular name. Here's what we usually do. We usually assign the first point the name, or the ordered pair, x sub 1, because that's the first x, and we assign the y value, the variable x sub 2, x sub 1, because it's the first point. So the first point is x1 comma y1. We do the same trick over here with the second point. We say whatever the second point is, that x coordinate is x sub 2, because that's the second x coordinate, and that y coordinate is y sub 2, because it's the second y coordinate. So this point here is x2, y2. And once we do that, we can create our slope formula, because all we'll do is do the same sort of math that we did in the last slide. When we wrote that formula out with the subtractions, what we had was m equals, the first number was the y value from that point, that second point, and we subtracted the y value from the first point. The denominator, the run, was the difference between the x coordinates. It was the second x coordinate minus the first x coordinate. And this thing turns out to be what we call the slope formula. It's a famous formula from algebra class, one of the most famous. M equals y2 minus y1 over x2 minus x1. And it's going to be important for us to get this thing copied down in our formula list and eventually memorize it. This is one of those formulas that you have to have memorized. It's y2 minus y1 over x2 minus x1. Now I do want to remind you how these rational expressions work, these big fractions. That big fraction bar in the middle there implies parentheses. So when you're doing this calculation, you want to make sure you subtract those two y values and the two x values first before you divide. Okay. Usually you'll end up with a fraction and we'll just reduce it. But if it is a fraction that you can divide the numerator by the denominator, please make sure you do the subtraction first. And if you're giggling as you watch this because I said these words wrong, yeah, I may have said it wrong before, but the numbers on the bottom are the denominator, the numbers on top are the numerator. Hopefully I didn't screw that up. Okay, so you've got this slope formula put in your notes, in your formula list. You've seen me sort of work my way through it with some pictures. Now let's try to calculate these slopes without any pictures at all, using the formula. Okay, this is take 2 at me attempting to find the slope between the points -1, 3 and 9, 6. I deleted the bloopers and I'm going to give it another shot here. Let's see if I can do this right. So, the trick is that we know this is going to be our first point. We don't need to draw a picture of that. We just need to assign x1, y1 to those coordinates. And this is going to be our second point. What we do first is we we list out the values of x1, which is negative 1, y1, which is 3, x2, which is 9, and y2, which is 6. It just goes from left to right. x1, negative 1, y1, 3, x2, 9, y2, 6. Once you have those listed out, we simply substitute them into that fancy formula that I showed you on the last slide. So we're going to say m equals, because that's the slope that we're looking for, m equals, it was y2, which is 6, minus y1, which is 3, over x2, which is 9, minus x1, which happens to be a negative 1. Recommend you put that negative sign in parentheses so we don't get confused there. And don't forget that this rational expression, this big fraction, implies parentheses. We're going to do the top calculation, then we'll do the bottom calculation and keep them separate before we think about whether or not we want to divide. And I think I can handle this. 6 minus 3, which is my rise, is going to be just 3. That's pretty good. And my run is 9 minus negative 1, which is just 10. So it turns out the slope of this line is the number 3 over 10. The rise over run is 3 over 10. So that's the slope. Your slope should always be a number. It could be a whole number. It could be a fraction. It could be 0. And in one case, when you have a vertical line, you'll get an undefined slope. All the other slopes are real numbers. Okay, let me show you on a picture how we do in fact get a rise of 3 and a run of 10 with these same points. Just to sort of reinforce that all we did was compute the rise over run when we did that calculation, I just want to show you by graphing this line that we do have the right slope. So the point negative 1, 3 is right here. The point 9, 6 is right here. And you know we could draw a line right through those points just like this, no big deal. We draw our lines long. And if we were going to do the rise over run with our triangle method, all we would do is start at this left-hand point and keep moving up or down, in this case up, until we were directly across from the other point. And then we'd move this way until we were hitting the point. And sure enough, my rise here is 3. And if you count these squares, you'll find that the run is 10. And so the rise over run method does give us the same answer. Right? We get a rise over run, and so that means the slope is 3/10. So yay, we had it right. It's time for the old smiley face. Insert whatever joke you want here about my smiley face. And now I'll show you one more calculation where we find the slope of a line passing 2 through points, and we don't have to draw a picture. So once again, we want to find the slope of a line passing through these 2 points. We're just given their ordered pairs. So we call this point right here x1, y1. We call this point right here x2, y2. You will list out those values. X1 is negative 11. Y1 is negative 12. X2 is negative 20. And Y2 is negative 1. Lots of negative numbers in this particular calculation. We won't panic though. We can handle these. So once again, our job is simply to substitute these 4 values into our slope formula. Our slope formula is m equals y2, which is negative 1, minus y1, which is negative 12. Put that second one in parentheses so we don't get confused with all the negatives. And in the denominator, we'll have negative 20 minus negative 11. x2 is negative 20 and x1 is negative 11. Now before I do the final calculation, let me clean this up a little bit. Instead of doing minus a negative, you know we can use that phrase keep, flip, change, and we could add the opposite. So this is really negative 1 plus 12. And in the denominator, it's really negative 20 plus 11. Don't forget, we're going to do these calculations separately. We'll do the numerator calculation, which is the rise, and the denominator calculation, which is the run, and we'll see what our slope is. So after a little quick thinking, I come up with 11. Negative 1 plus 12 is 11 for the rise. And the run looks like it's going to be negative 9. So the slope is 11 over negative 9. You know that I usually write my negative fractions with the negative in the numerator. So I would say this is negative 11 ninths. No need to make this an mixed number. Remember, slope is this ratio of the rise over the run. It's a rate of change, right? So we really want to have this as a fraction. And if it's an improper fraction, so be it. The slope here is negative 11 ninths. Okay, we've run through the whole idea that slope is this ratio of rise over run. We reminded you how you pull the rise and run off a picture by drawing the triangle in. And then we've abstracted that process into a formula where, as long as you know the 4 values for x1, y1, x2, and y2, the coordinates for the 2 points, you can plug those into a formula and you can calculate the rise over run without ever seeing the picture. And that's what this lesson was about. It was about introducing the slope formula. So now what we need to do is practice using this slope formula so we can then move on to solving some more interesting problems that involve slope. Good luck.